Hey guys, it's Mr. Elting here, trying to help you out figuring out these uniform motion problems. Let's just start this one off. You know how to make our chart. We'll go ahead and do that, assuming you know what to do. Um, Again, you always have, the two columns and the three rows, and we're going to put our distance formula on top, which hopefully you got that question right. It's R times T equals D. Rate times time equals distance. And we'll put our two objects here. In this one, it's automobile. We have two different automobiles. So I'm just going to say car 1 and then car 2. After I have this, let's start filling some things in here. If we look here at our rates, it tells us what our rates are. It's 25 and 35. I think that's pretty clear. Well, the first one, 25. The second car, 35 per hour. Now, what would go in the time here? Well, they're starting at the same time. And then it looks like they're going, and then as soon as it hits 180 miles apart, we're sort of done. So they're going to take the same amount of time. So we have X and X on this one. Now, how do I get over here? Well, again, not too difficult. You just multiply R times D equals D. So 25 times X is, it's not too bad, 25X. 35 times X is the same. And now we have just the end of this problem, which really shouldn't be too difficult. We just have to figure out that stupid equation. The first key is we need to identify the type of motion that this problem is. Now, if you read carefully, I think it's pretty clear. It says opposite directions. So if I reference that flow chart that we talked about in class, opposite, you're always adding the directions. You're always adding the distances, rather. To get the total distance. And guys, let me be honest with you, you could always just use this flow chart. Do they give you a total distance in the problem, yes or no? Let's go back. Yada, yada, yada. After how many hours? They were 180 miles apart. That is a total distance. So yes, they give the total distance. Doesn't even matter the type of motion. We are going to add those. So let's go ahead and do that. We have 25x and 35x. Those are the distances. They're in the D column. Those will add up to 180. And now it's just a matter of solving this equation. Go ahead and do that, and let's see what we get. If you did this correctly, you should have done 25x plus 35x is 60x equals 180 still. And then to finish this off, you got to divide both sides by 60 to end up with x is equal to positive 3. And if you put that back in the context of the problem, that means after 3 hours, they were 100 miles apart. So did we answer the question? Absolutely. It's 3 hours. Very good if you got that.